Chapter 6, Section 5 on graphing tangent and cotangent. So we know from the unit circle that we have some easy x's, which are our angles, like 0 degrees for sine and cosine, 90 degrees for pi halves, which gets us 1 or 0. So we have 0, 1, we have 1, sorry, switch those. Sorry about that. 1, 0, 0, 1. At pi, we're at negative 1, 0, and 0, negative 1. Right, but when we look at tangent of these, well, tangent is y over x. Y over x. Y over x. And y over x. Well, 0 over 1, that's 0, so that's good. So tangent of 0 is 0. But tangent of pi halves, well, that is 1 over 0. Well, I can't divide by 0, so that's undefined. And then if I go around, I get tangent of pi, which is 0. And then tangent, that's 0. Tangent of 3 pi halves, that is undefined again. Undefined. And then at 2 pi, we're at 0 again, right? But this time, 0, undefined, 0, back to undefined. So it's already repeating itself. It actually repeats itself right here as it's starting to repeat itself. 0, undefined, 0, undefined, and then 0, right? So it starts to repeat itself again. So our period length for tangent and cotangent, because cotangent is just reciprocal, is pi. So if I want to find my period, I just take pi and divide it by b. So then my interval length is just that divided by 4, which is the same thing as that. Pi 4 over b, or pi over b times 1/4. And so there's my interval length. And here the only difference is it's hard to graph those. It's hard to graph 0 and define 0. So if I was graphing that, it'd be 0, next x is undefined, next x after that is back to 0, and the next one after that is back to undefined, right? And you notice that it repeats itself right here is where it starts to repeat itself. So that's kind of hard to graph. So we kind of need the in between. Well, what's happening in between here? Well, that's at 1/4 pi, and we know tangent for that is just 1 and 3/4 pi, which that's just a negative 1. Right? So those are a little easy. So if we go 1/4, we're at 1. And at 3/4, we're at negative 1. So what's happening in between here? Okay, so that's why tangent's a little bit different. So tangent actually starts out at down here at negative pi halves. So it actually starts at negative pi halves and goes to pi halves. So negative pi halves to pi halves. So that's the normal period, or where we kind of start our interval. So it starts at negative pi halves and it goes to pi halves. That's tangent. Where normal, all the rest of them are at 0. But cotangent is a little bit different because it's undefined right here, right? So it's undefined there, and then it's at 0 here, and then back to undefined. So how you do with tangent and cotangent is you always start at an undefined, y value of undefined, y value of undefined, so tangent of x is always going to give you undefined. That's what we have here at negative pi halves, undefined, and then 0, and then, negative 1, 0, 1, undefined, because we're going here in between the quarters. So if this negative pi halves is undefined, negative 1/4, that is at negative 1. Normal 0 is at 0. Then at pi halves, we're at positive 1, and then at just, quarter pi, we're at 1, and then just at pi halves, we're back to 0. So that kind of is how it works for tangent. And so cotangent is a little bit different. Cotangent, well, its first undefined is actually at 0. It's undefined. Then at a quarter pi, it's at 1, just like tangent. And then half a pi, that is back to 0. Where tangent's undefined, cotangent of pi halves is 0. Then at 3/4 pi, it's at -1, just like tangent. And then cotangent of pi is back to undefined, where tangent is 0. So for cotangent of an x, of these x's, it goes undefined, 1, 0, -1, back to undefined. Okay? So we're going to use those same y values just like we did on sine, cosine, and tangent. So we'll always multiply these by our a, and then add c to them. So we'll multiply them by a, and then add c to them to find our new y values, our 5 y values. These will never change as undefined. Undefined. But these 3 will change. They'll be affected by our a's and be affected by our c's. And then our x values, for tangent, we normally start for our x's at -pi halves, and we normally go to pi halves. Where cotangent starts at 0 and goes to pi. And our period length for both of these is pi over b. And our interval length is pi over 4b, because we take our period and multiply it by pi fourths. Okay, but again, what you can really do, another way which talked about in class, is instead of finding your interval length and then finding where your first x is and then adding your interval length to get to your second x, and then taking that second x and adding your interval length to get to your third x, and so on all the way till you get to your fifth x. Okay, what you can do is you can take your normal x's, normal of tangent, normal x's of tangent is -pi halves, -1/4 pi, 0, 1/4 pi, and pi halves. So I can take whatever I'm taking tangent of, whatever's in here, I can set it equal to this, I can set it equal to that, I can set it equal to that, and I can set it equal to that, and that one, and that will give me all my x's that I need to graph. Where cotangent, my x's would equal 0, 1/4 pi, pi halves, 3/4 pi, and pi. And again, I would set whatever I'm taking the cotangent of and set it equal to each one of these to find my x's that I need to graph. So first x, second x, third x, fourth x, fifth x. Okay, so there's 2 ways that you can find your x's. All right, so looking at this, basically kind of same thing as we've done before, right? Period is just normal pi, divide that by 4, or sorry, divide that by our b, which is what's being multiplied by x, so that's 2. So our period is pi halves, and then I multiply that by 1/4 or divide by 4, so I get pi 8. So there's my interval length down here, sorry. My interval is where we normally start. So normally at tangent, I start at -pi halves. So I'm going to set that equal to what I'm taking the tangent of, which is 2x. And then I'm going to solve for x. So dividing by 2 is like multiplying by half. So my x is equal to -pi fourths. So that's where I'm going to start. And now I can add my interval length, which is pi 8. So I need to get a common denominator. So -2/8. And then I can add pi 8s. So that'd be -pi 8s. Add another pi 8s. Pi 8s. I get 0, pi 8s. And then add pi 8s. Jeez. 2 pi 8s. And we can see that this distance is 4 pi 8s, which is the same as pi halves. And then my y values are undefined. -1, undefined, or sorry, 0, +1, and then undefined. And it kind of looks like a cubic. So it kind of goes that way, and kind of goes up that way. So it kind of looks like a cubic, and that repeats itself every pi length, right? Or for this case, it's pi halves length. All right, a couple more minutes of this, because these are all really the same. Pi divided by my b is 1/2. So when I divide by 1/2, that's multiplying by 2, so I get 2 pi. So I know my interval, I normally start at negative pi halves, so I'm going to set that equal to what I'm taking the tangent of. So that's 1/2 x. So again, multiply by 2, I get negative pi. So this is actually going to start at negative pi. This is negative pi. My interval length is taking my period, which is 2 pi, and divided by 4, so which is pi halves. So I need to switch this to, instead of negative pi, it's going to be negative 2 pi over 2. Common denominator, so now I can add my interval length. Right here's my interval length, pi halves, so I add that and I get negative pi halves. Add my next interval length, so I get 0, add another interval length, I get pi halves, add another interval length, and I get pi. And I can see that this distance is a total of 2 pi, which is my period for this problem. Okay, then my normal y's are undefined. -1, 0, 1, undefined. So it's normally 1, 0, -1. So now I multiply by my a. Here's my a, 3. So that becomes 3. This still becomes 0. This becomes -3. There's nothing added at the end. So there it's done. Now I can kind of draw a cubic looking thing. There you go. Okay. Same thing kind of here, except for it's a negative, so that's going to affect it a little bit. 2x, so that's going to affect my period. So I divide it by 2, I get pi halves. Don't really need to change that. Divide that by 4 or multiply by a quarter, I get pi eighths. Interval is normally pi halves. Set that equal to what I'm taking the trig function of. So divide by 2 is like multiplying by half. So x is equal to negative pi fourths. Ooh, that's a lot of writing there. X is equal to negative pi fourths. So there's my first x. Negative pi fourths. Here's my interval though. So I need to change this, right, to 2 pi eighths. So then I have common denominator. I can add my interval length, which is pi eighths, so then negative pi eighths. Add another one, pi, or 0, sorry, pi eighths, and then 2 pi eighths. And again, we can see this distance is a total of 4 pi eighths, which is the same as pi halves. Okay, then normally my y values are undefined, -1, 0, 1, undefined. So now I'm going to multiply by a, which is a -1/2. So this stays undefined. A -1/2 becomes a +1/2. Or -1 times a -1/2 is a +1/2. Still get 0 here. We get -1/2 here, and this one's still undefined. And again, we're not adding anything. So now still undefined. At a half, so we'll just label that as a half. Actually, probably need to bring that up here because positive's up here, right? So let's label this one +1/2, 0, and -1/2. All right, so a half, 0, -1/2, back to undefined. And again, it's like a cubic looking thing. So it looks like that. There you go. All right, here we're kind of adding a c, so that's going to change our y values. This is just plain tangent of x, so that goes undefined. Starts at negative pi halves, then quarter pi, negative quarter pi, 0, quarter pi, and then negative or positive pi halves. And it goes, normally it goes -1, 0, +1. So it looks like this, because we're not moving this left or right, so my x's don't change. I'm just adding 2 to it. So this normally 1, this is going to change to 3. Or sorry, yeah, 3. This 0 is now going to change to 2. and this negative 1 is now going to change. It's going to move up 2, so that's a positive 1. So there you go. All right, let's do a cotangent with everything in it. All right, so period length of cotangent is just normally pi, divide that by b. Our b is just 1, so there's nothing being multiplied by our x except for 1. Okay, so it's just pi. And we're going to take that and divide it by 4, so pi quarters, whatever, pi fourths. Okay, so normal interval length is 0. So I'm going to set what I'm taking my trig function of and set it equal to 0. The only one that's different is tangent. All the rest you can set equal to 0. So that's pi fourths. So that's my first x. And then I want to add my interval length, which is pi fourths, so that's 2 pi fourths. And the next interval would be 3 pi fourths, 4 pi fourths, and 5 pi fourths. We can say that total distance is 4 pi fourths, which is pi. Okay, then my normal y values are undefined, positive 1, 0, negative 1, and undefined. We're going to multiply them by our a, which is negative 1 right here. It's a negative cotangent, so negative 1. So undefined, negative 1, 0, positive 1, undefined. Then we're going to add our c, which is a negative 2. So that's undefined, negative 3, negative 2, negative 1, and undefined. So then the highest y value here is negative 1. Middle y value is negative 2. The lowest y value is negative 3. Then it goes undefined. Last one is undefined. And then first one is negative 3. So negative 3. Oops, move that over a little bit. Negative 3, negative 2, and negative 1. And it looks like a cubic. There we go. So that's kind of how you graph these. 17 minutes, that's not bad for tangent and cotangent. You can practice more if you want to. Oh, I guess maybe I need to do this. Sorry, maybe 20 minutes. Here's writing an equation. So writing an equation, we want to find our basically our a, our b, and our c, our a, b, and maybe our phase shift, what kind of happens in the middle here, and our c, how we move up and down. Okay, so how we kind of look at this is our period length first. So how far does it take to repeat itself? So that distance is pi, and here we're looking at cotangent or tangent. So tangent normally starts at negative pi halves and goes to pi halves, so we're looking at probably writing tangent equation for this one. Where this second one starts at 0 and goes to 4 pi, so it's probably a cotangent because it starts at 0. It's just easier that way. So this one, this period length of the blue one is just pi, and so when I normally take that, I divide it by b, and that's how I find my normal period, my period length, right? So if my period length is just pi, I can set this equal and solve for b. Multiply both sides by b. Don't really have to, but divide by pi. The pi's would cancel as long as the b's. So my b is equal to 1. So that's a little bit harder work. So my b is 1, so it's just plain x in here. And then, so that's how I find my b. My a is what's being stretched, okay? So normally my y's are, for tangent, are negative 1, undefined, and undefined, negative 1, 0, 1, and undefined. Well, here the undefineds always stay the same. But here I notice that my first one, I usually get negative 2, but this one is a 2. So how do I get from negative 1 to 2? Well, I multiply it by negative 2. So there's my a, negative 2 equals negative 2. Okay, so there's my a, negative 2. Because this value right here also stays at 0. So multiplying that by negative 2 is still going to keep it at 0. Taking this value, which is normally a 1, multiplying that by negative 2 is going to give me negative 2. So I'm good. So that's why it's negative 2. This one I didn't. Oh, there it's labeled. Okay. And then nothing's being added to it or subtracted from it, so we're good. And yeah, that's fine. It's not being shifted to the left or right, so we're good because it started out where normally tangent starts out. So there's my equation for that. Cotangent normally starts at 0 and goes to pi. Well, this one goes to 4 pi. So I want to set pi over b equal to what it is, this length, whole distance here, which is 4 pi. So now I'm going to solve for b. So again, basically these can switch places. All right, so the pi's will cancel out, so I get a quarter. So b for this one is a quarter x. Okay, and then I don't shift over. So how I figure out if there's a shift in between here, if there's an adding a number or subtracting a number, I look at where I'm starting and where I normally start cotangent. So there's no shift. So if there was a shift, I would set whatever this number is equal to where I normally start cotangent, or where I normally start tangent. Okay, and then so there we go. So that's it for inside there. Now I have to figure out my a. So right now I have a 0, -1, and a -2. But normally cotangent is, I need some more room. You're probably thinking I have no idea how to do this even after this video. Well, it just takes more practice. So normally cotangent is undefined, 1, 0, -1, and undefined, where our values are undefined, undefined at the end, and 0, -1, and -2. So how do I get there? Well, I can't really multiply a number. Well, there's a few different things you can check out here, because I can multiply by some a, or I could just add a c, right? So maybe if I just subtract 1 from each of these, I would get to these, right? That'd be 0, that'd be -1, that'd be -2. So all I'm doing is just subtracting 1 from each of those. So here there is no a, so I'm just going to subtract 1 from this. So add a -1. And there's the graph's done. It could be many different things. Maybe I could multiply them all by 2. No, gonna do the 2 thing. So that one's gonna be it. Or maybe you can multiply by -1 and then move it all up to maybe, I don't know. Best way to see is just subtracting 1 from all of them. Okay, so those are the 2 equations you can write. These definitely are going to take more practice and harder to do. But hey, under 23 minutes, that's not too bad for the whole section.